Hello, so we'll see the composite high pass filter design by the image parameter method. R0 is 75 ohm, cutoff frequency 50 MHz, and infinite attenuation pole frequency is 48 MHz. Being a high pass filter, F infinity is less than Fc. And we know that composite filter consists of 4 sections. You have matching section at the input side and another one at the output side, and we have constant K and M derived section. So first we'll write the formula for omega C. Omega C is 2 pi Fc, and omega infinity will be 2 pi F infinity. They will be in radian per second. Now first we'll design the composite constant K T section network. So this is the network for the constant K T. So L is given as 2R0 by omega C. So we have R0 as 75 ohm and omega C as 2 pi Fc. So after substituting, we'll get the value as 119 nanohenry, and the C turns out to be 21.2 picofarad. But here the component value is 2C, so it is double of this one, so it turns out to be 42.4 picofarad. And the value of L is same as this one, which is 119 nanohenry. So after constant K, we'll proceed for the designing of M derived section. And for M derived section, one has to calculate M. For high pass filter, M is given as square root of 1 minus omega C by omega infinity by omega C the whole square, or 1 minus F infinity by Fc the whole square. So we'll substitute these values, and M turns out to be 0.280. So we'll use this M for designing this M derived T section. So the formulas are, or the component values are 2C by M, you have L by M, and here it is 4M by 1 minus M square into C. In high pass filter, the M is in the denominator of the M is in the opposite side of the component, while that in low pass filter M is with the component. You can observe this thing. So now we'll calculate these values. So this turns out to be 151 picofarad, and L by M 119 divided by 0.280 turns out to be 425 nanohenry, and the value of this capacitor is 25.8 picofarad. Being a high pass filter, the capacitors will be in the horizontal arm, while the inductor will be in the vertical arm. Now we have to design the matching section where M is equal to 0.6. So we have bisected by matching network where M value is 0.6. So we have to copy, as I mentioned in the last lecture, we have to copy this part of the network as it is over here, and one has to split this 4. So 4 is in the numerator, so we'll split like this, 2 over here and the remaining 2 will be over here. One can memorize in this manner, and they can calculate the component values. So here it will be 2 into C, that is 21.2 pico, divided by 0.6. So it turns out to be 70.7 picofarad. Here it will be 2 into 119 nano divided by 0.6. So it turns out to be 397 nanohenry, and this component again it will turns out to be 39.8 picofarad. But to select M is equal to 0.6 for designing bisected by matching section. So now we have to place these 3 sections, or rather 4 sections, one after the other. So your network will look like this. So first we have bisected by matching section, The output of this one will be given to constant K section. Then you have M derived section. And at the end you will have this bisected by matching section, but mirror image of this one. Be careful. So we'll have R0 is equal to 75 ohm over here, and one can have R0 is equal to 75 ohm over here. So this is my port 1, this is my port 2, and we have designed this component filter. We will write down the component values. So here it will be 70.7 pico. Inductor is 397 nanohenry. And this is 39.8 picofarad. Now this is constant K T section network, so these values are 42.4 pico, and the value of this inductor is 119 nanohenry. And this is M derived section. It is used to in M derived section we place the infinite attenuation pole frequency just before the cutoff frequency in case of high pass filter. So this value is 151 pico. So that completes the design of composite high pass filter by image parameter method for the given specification. If you have any query, you can mail it to me on this email ID kadam.ameya@gmail.com. Thank you.